Okay guys, we're about to do experiment 4 for Chem 110. This is quantitative solution chemistry, and this is our first titration lab. So we want to make sure that we're as accurate and precise as possible. That means we want to be very careful with all of our measurements. And so the first thing we're going to do, we're going to prepare our standard solution. So I have here the potassium ferrocyanide trihydrate, my weigh boat, and I have a 50 milliliter beaker. Then over here, here's my volumetric flask, which we'll talk a little bit about later. And we have everything we need to make our standard solution. Okay, so the first thing we're going to do, if you look at your procedure, is we're going to mass a 50 milliliter beaker. So I tear the balance. Okay, so that beaker weighs 31.9069. grams. Okay, so now we need to get a precise weighing. And you might remember from the previous lab that I actually didn't want to add any solid to the, while I had my beaker in the analytical balance, because then I might make a mess. That might damage a very expensive piece of equipment. So we're going to use the top loader balance in conjunction with the analytical balance to get a very accurate mass of our potassium ferrocyanide. So what I'm going to do, I'm going to tear my top loader balance. I'm going to put a weigh boat on the top loader balance. And then I'm going to tear the balance again. And this, what I'm going to do is I'm going to add my an approximate amount of potassium ferrocyanide trihydrate. Based on the calculation you guys do with the pre-lab, I'm not going to give away the exact number, but it's around 1 gram. Do I need to precisely get 1 gram? No, I'd be here forever doing that, even though I have a lot of experience with weighing things. I'm going to get around 1 gram. It doesn't matter if it's 1 gram or not. What matters is that you know to a high precision the mass of your sample. So I'm going to get around 1 gram. About halfway there. That looks about good. So I got about 1.12 grams. Now that's not the most precise measurement we can get. I do have some solid left, so I'm going to mosey over here and grab an excess solid container, one that doesn't look full. There we go. Actually, I'm not going to do it that way. Let's see, what can we need to put this somewhere? We'll put it in the speaker here. It's a weigh speaker. Okay. So, and I'll get rid of that in the waste bottle later. So now, what I'm going to do is I'm going to transfer the solid from the weigh boat to my 50 milliliter beaker, which I pre-weighed. Now, does it matter that I got every single grain of solid out of the weigh boat? Actually, it does not, because we're going to use the analytical balances weighing for what will go into the volumetric flask. So it doesn't matter if we get all of that out of the weigh boat, as long as we get a good precise mass of what we did get out. So let me redo that. Tear. It's taking a while because we're close to. Okay, so we're going to tear Add that. Wait to stabilize, and that gives us 33.0237. Okay, now you'll take the difference between the mass of the beaker and the mass of your sample plus the beaker, and that'll be your mass of sample that you'll use in your calculations. All right, so now let's go over here. Now we're going to make our standard solution. So we're making a standard solution in a way that we're going to precisely know the concentration, so the molarity. So two things we need to know precisely. First is the volume, and that's why we're using a volumetric glass. This is a high precision piece of glassware. There is a mark that's probably pretty difficult to see there. If you add enough water or solution so that the meniscus hits that line, that means you've added precisely 100.00 milliliters of solution. Okay, and there is a tolerance on here, just like the tolerance as we saw for experiment 2. The tolerance is plus or minus 0.08 milliliters. So 100.00 plus or minus 0.08. Okay, so the uncertain digit is the hundredths place there. Okay, so that's how we'll know the volume precisely. We need to make sure that we know the mass precisely, which we did a very accurate, very precise weighing. But now we have to make sure we get all of this potassium ferricyanide out of the beaker. This is called a quantitative transfer. So the way that we're going to do that is I'm going to add some water. I'm going to do a little bit of a swirl here. And let's get, always drawer surfing here. Let's see if we can get a glass rod. Not here. It's over here. Oh, here we go. Doesn't look the cleanest. Just clean that off real quick. There we go. Nice clean glass stir rod. And dry. Okay, so we're going to come over here. So I added some water to my beaker, and I'm going to stir to get as much of that to dissolve as possible. So it is dissolving. This is pretty soluble in water. Oh, yeah, it's dissolving very nicely. So now a tiny bit more water here. Help with solubility. Okay, that's most of it. So then what I'm going to do is I'm going to add this to my clean and dry volumetric flask. So let's get a funnel. More drawer surfing. I don't see a funnel there. Here we go. Nice. Looks pretty clean too. Okay, so let's get our funnel in there. All right. So now there's might be a smidge more, not very much more. I think we got it mostly cleared out there. So I'm going to Add a little bit more water. Give it another stir. And that should get whatever small amount remains. Okay, so that was my quantitative transfer. So I don't see any more in here, so I got it all out. Okay, so now what I need to do is I need to fill up to that mark. So what I'm going to do is I'm going to add water until I almost, very slowly here, until I almost fill that bulb, which I'm at that point right now. Okay, now what I'm going to do is I'm going to use my wash bottle here, fill it the rest of the way. And the reason why I switch is because I have more control over the wash bottle than I do over pouring from a beaker. Now I'm at the point where I'm almost to the line, and I'm going to get even more precise here. And I'm going to grab a dropper pipette. And add until that meniscus gets pretty close to the touching the line. There we go. All right, there we go. Now, why did I do that? We want to get that volume pretty precise, but I also want to make sure I didn't go over the line. If I went over the line, I'd actually have to start all over again. Nobody wants that. All right, so now I'm going to put on my snap top. I'm going to do another pretty important step here. There we go. So I'm going to invert this a couple of times. And why am I doing that? So that is to make sure that things are very thoroughly mixed. Because what I don't want is like I don't want the bottom of the solution to be more concentrated than the top of the solution, because that means that when I titrate, you're going to get very different volumes of zinc sulfate added, and we don't want that. All right, so you have a good mix, and there we go. You have it, our nice standard solution. That's how you make a standard solution. Alright guys, we're ready to start part 2 of our experiment for quantitative solution chemistry, and what we're going to do now is titrate our potassium ferrocyanide with zinc sulfate. So I have my burette here. Let's move it back. Burette. It's already set up. I rinsed it out first with water and then with some zinc sulfate to coat the walls of the burette with the solution we're titrating with, our titrant. It's the official name of what we put in the burette. Okay, and I've already prepped 2 of my 3 trials here with what we need, but we're going to make one solution so you can see how that works. So the first thing I'm going to do, I'm going to use to prep my solution is I'm going to have to add a precise volume of our potassium ferrocyanide solution. And to do that, I'm going to use this piece of glassware. This is called a volumetric pipette. It's a high precision piece of glassware, just like the volumetric flask was. And works pretty much the same way in terms of there's a marking up here, and when you fill the pipette so that the solution's meniscus hits that line, then you have precisely 25.00 milliliters of solution in the pipette. And there's a tolerance on here as well. Here it is, it's 0.06 milliliters. This is what allows us to say that we have a 25.00 milliliters if you fill to the mark. Now to use the pipette, you're going to have to use a pipette bulb, which you may have used in high school or sometimes even in some of your biology labs. These are the ones we have in the chem department. There are 3 buttons here. The first button has an A, so this is the aspirate, or this pushes the air out of the bulb. So I press that now and squeeze the bulb, then it stays squeezed in since all of the air is gone. The second button of interest to us is the S, that's the suction button. When you press that, you end up using a vacuum action to suck up the liquid from the container into the pipette. You'll see that the bulb actually inflates as that happens. Because as the bulb fills with air, that creates that partial vacuum that sucks up the liquid. And then finally, we have the E button, that's the evacuate or empty button. And that lets you control letting out the liquid. And in this case, since we're filling the pipette with a liquid, it's okay to evacuate some as you adjust where the meniscus hits that line. Okay, so here's what's left of my standard solution. Like I said, I already prepared our 2 solutions. So here's my pipette. So I'm going to put it on there. You don't want to jam it. Sorry, I was checking the camera there. You don't want to jam it in. You just want to stick it in there. I'm going to hit my A and let out all that air. Okay, and now I'm going to stick it into the volumetric flask. And then I'm going to hit the S button. You see that liquid is being drawn up. It's going to take a while to fill that that bulb there. Sometimes you run out of air, or the bulb completely inflates before that's okay. You just you can take it off and re-aspirate. Okay, so now I'm up in the neck of the pipette. Too much. Okay, that's pretty good. All right, so now I got what we need. I'm going to come over to my 250 milliliter flask and let that liquid out just by taking the bulb off the top. So that lets the liquid out pretty quickly. So now I have 25.00 milliliters of potassium ferrocyanide solution in my flask. So I know the volume to a high precision. We know the concentration now to a high precision. So that can give me moles to a high precision. All right. Now we have to add some more things to our solution. So the first thing we need to add is about 5 milliliters of sulfuric acid, and because we're going to do that, I'm going to put some gloves on. That is corrosive, and also the DPA, diphenylamine, is pretty corrosive too. So let's put on gloves. All right. So now I'm gonna come over here, get that. Okay, I like to use the pipette for the smaller volumes just because you get a little bit more control. Okay, there we go. So we're going to add that to the solution. Now we are going to add 3 drops of potassium ferricyanide, so K3FeCN6. Okay, so it's about 3 drops there. Swirl it around. Okay, so there's that. And now we're going to add 2 drops of diphenylamine, so 1% diphenylamine and sulfuric acid. So that's kind of toxic and corrosive, so hence the gloves. All right. Okay, so now we're all ready to titrate. Okay, now we're ready to titrate. So I have my titration set up, my burette, and my trial 1 solution. Okay, so the point is we want to add, just like we saw in the pre-lab video, until we see a persistent light purple color. Okay, so the first thing I want to do before we start adding zinc sulfate is I want to get a good initial burette reading for my first trial. So that'd be 0.9, say 0.94 milliliters. So let's get my book here. Okay, now I'm going to add, and now we don't really know where the equivalence point is. I kind of do. So what I'm going to do is I'm going to add, I'll start adding some. I'm going to add about 5 mils to start. Look, we get, so what we get here is, you can see that it's a little discolored here, so I have the white paper so you can tell. So we're forming some white solid, like a grayish white solid there, which is one of the reactants. Okay, let's add let's do another quick add. Okay, still white. So we added almost, let's say about 9 milliliters now. And I kind of know where the equivalence point is. So. And look, we're swirling. We want to make sure that our mixture is everything is well mixed. Set this to a slow drip. So what you might be able to see there, and you might have seen it sort of at the beginning, is there are some little flashes of purple here, which is telling us that we're getting pretty close to our equivalence point. I'm going to set this to dropwise. So what I'm doing is now I'm going to start adding slowly. So now it's adding dropwise. Yeah, it's definitely flashing purple. You see that there. Oh, here we go. Looks like we have a permanent purple color. Okay, so that's our endpoint. Okay, so now we're going to read the burette again. to get our final burette reading. $21.51. Something about 20 milliliters, give or take. All right, so that's our first trial. Okay, now we are ready to do our second trial. And good news, we know about where the equivalence point is. It's around 20 milliliters or so. So we don't have to add as slowly as we did before, even though that wasn't the slowest we could have added. But so we're at 21. So let's say it takes maybe close to 41 milliliters. So I'm gonna add maybe about 10 straight milliliters here. So now that we kind of know where we stand, I'm gonna keep swirling as we add. It's close to 10. Our initial burette reading is where we ended, right? So let's write that down before I forget. Okay. So now we come back over here. And now I'm going to add another quick few milliliters. Oh, it's starting to flash the blue again. Means we're getting close. So now I know where it is about. I can do a better job of titrating. Maybe I can get a paler purple color. I'm gonna set this to drop wise. So what I'm doing is now I'm gonna start adding slowly. There we go. There we go. Nice. Okay, there we are. That's a little bit paler than before. We're getting better. All right, let's read our burette again. What am I doing? 41.1. Or 41.20. Okay, now we're ready for our last trial. So we're pretty well practiced at this now. But we're getting down to close to 50 again. We know it takes about 20 milliliters. So let us refill burette. Zinc sulfate right here. Don't have to fill it all the way back up, but at least enough so that we can finish our last titration. What did I do? Fill it almost to the top. That's okay. All right. So let's get our third trial in there. Okay, let's read our burette. Since we did have to add more solution. So 1 point. $1.75 milliliters. that 1? No, sorry, 1.75. Maybe I'm at 1.65. 1.65. I apologize, guys. Visually impaired to be right. It's not the easiest thing for me to read. Okay. All right, now let's take a look at this one. Okay, so we know it's close to 20, so we can do a very quick add. About 14 milliliters. Oh, didn't overshoot, didn't overshoot. Let's swirl. So now I'm going to start it to drop wise. Getting close. Here we go. All right. So 22 point. 22.29. 22.29. Okay, we're done with our titrations. You can see over here that they do fade over time, the colors, which is pretty interesting. Trial 2 actually faded all the way to white. It was definitely persistent purple. Okay, so we're all done with experiment 4. So go forth and do all of our calculations. Have fun.